All right, hello again, ladies and gentlemen. This is Notes Lesson 1.4, Function Operations. And you have an IXL to do, and this is entirely algebraic. And I have a numeric function operations worksheet that is working with numeric function operations, but also graphical as well. So it's a very easy worksheet. There's not a lot of work to show, but it's absolutely necessary that you remember that we can do things with algebraic operations and x's and stuff, but we can also do it just with pictures of graphs of functions. And it's really important that you can work between them very easily. So function operations. We can take functions and combine them using all kinds of our regular mathematical skills: add, subtract, multiply, and divide. And so this is notation. We want to understand what they're talking about. And so we have some, I call it old school and new school notation. I really don't like the new school. The new school notation says, I'm going to add two functions together. So we can use f plus g of x. And I don't like this because it looks like f plus g and then times x, but it's actually not. It really means f of x plus g of x. And this is the old notation. Hey, let's just write it like this. And they're like, hey, let's get rid of one set of parentheses. Like, no, let's just reorganize. I don't, this isn't better. I hate this notation. But you need to know that these two things are equivalent. This just says, let's add two functions together. Pretty straightforward. This looks like you need to distribute and that we're distributing the x, and that is not what's happening here. So be sure you understand this is just notation. Sometimes when they use the x, it means in terms of x. But sometimes we might have a number here where they actually want you to plug in a value. And so it might be in terms of 2. So you might plug in 2s, or in terms of 4s and plug in 4s. We can subtract functions as well. We could do f minus g of x, which really means f of x minus g of x. And of course, I like this much better, okay? We are subtracting, so be careful that you remember that you need to distribute your negative, because you are subtracting the entire g function. It could be a very big thing, so you need to subtract all of it. So be very, very careful. We can multiply fractions. So we could write it fg, and when two things are right next to each other, it means f times g. So we would say fg of x, and that means to multiply. Really means f of x times g of x. Okay, and again, this is just distribute and combine like terms, so just multiplying things together. We can also divide. We would say f over g. You could shorthand it f over g. That's very good. But sometimes they write it f over g of x, which I think is silly. And it really just means f of x divided by g of x. And there's a caveat on this one. You have to remember that g of x is not allowed to equal 0. Because if you had something divided by 0, that would be undefined. My favorite saying is, when the 0 is under, it's undefined. So whenever you're dividing by 0, we get an undefined answer. We cannot answer it. It is undefinable. All right. So that's just notation. So I'm going to show you what it looks like. So example 1. The graphs of generic function f and generic function g are given. Use them to answer the following. And you might need to take a second to copy down, make a sketch. They don't have to be beautiful, but you definitely want to have a reference here. So make a quick sketch of these graphs, pause the video, and then go from there. Okay, so hopefully you've had a break and you've written those down. We have this crazy notation. I don't like this. So I'm going to rewrite it and tell you what exactly it means. So it really means, this says f plus g of negative 3. It's not multiply by negative 3. It's not negative 3f minus 3g. It's not that. It's f evaluated at negative 3 plus g evaluated at -3. And this is function notation. So what we do here is we say, hey, go to the f function. There's the f crazy graph. And go where the x value is -3, right there. And it's asking for the output. We have the x at -3. It wants to know what's the y value. Well, the y value is right here at 1. So f of -3 equals 1. And then we need to figure out, well, what's g evaluated at -3? So there's our g function right down here. And we want to go to -3. There it is. And we know the x value. It wants to tell you what's the y. And so the y value right here is 2. And so then we say, well, 1 plus 2, hey, that's 3. And that's our answer. So we're just adding values together. Subtracting. This says g of -1 minus f of -1. So that's the old school notation. I think this is way more meaningful. So g of -1 says go to the g function right down here. Go to -1 for your x value, and it's asking what's the y. Well, right here, the y value is -2. Oh, and look that was a mistake up here. That should have been -2, which means I was wrong. Hey, glad we fixed that. All right, very important. Don't forget those negatives. All right, and then we're going to subtract, and we want to figure out what's f of -1. So we go to our f graph here, and we go to -1, and its output is up here at 2. So we have -2 minus 2 is -4. And here, again, this one says we're multiplying f times g at 0. So that really just means f of 0 times g of 0. All right, we can do that. F evaluated at 0, right there, has an output of 3. And g evaluated at 0 has an output of -2. Boy, things are boring. And so then we multiply those together, and we get -6. Last but certainly not least, we have f of 2 divided by g of 2. So really, this is just really important that you understand the notation. Once you understand the notation, then function operations is super easy. So f evaluated at 2 has an output of +2, and g evaluated at 2 has an output right here. The output, the y value is 0. Uh-oh. Can we do that? When the 0 is under, it's undefined. When the 0 is under, it's undefined. You cannot have a denominator of 0. Very, very important. If the 0 was in the numerator, is that okay? Yes. 0 is a fine answer. All right, so now you'll notice those previous ones were all numeric. They had numbers in place of x's. Here you can see that all of these are going to be in terms of x, and that's what that means, in terms of x, and that's a very literal statement. So this is f of x. This is f in terms of x, which means, hey, look, there's 2 terms, and look, one of them has an x. Or here, this is g in terms of x, and that means that, hey, look, there's some terms there. There's 2 terms, and they both have x's in them. How about that? So it's a very literal statement. Again, f plus g of x really means f of x plus g of x. So I'm going to color code these. So here is our lovely pink f of x function, and our lovely green g of x function. And we're basically just substituting. In place of my f of x function, I'm going to put in what it's equal to, which is 2x plus 1, because I only want it in terms of x's. I don't want f's. I don't want g's. I just want x's. And then g of x, we're going to replace, so there's a plus sign in the middle there. We're going to replace g of x with x squared plus 2x. Great. That wasn't hard. And now we can just combine like terms. I have an x squared, I have a 2x and a 2x. That gives me 4x's, and then my +1. And so this is f plus g. And f plus g is a great shorthand. I think that's the only reason they use it, is just so they can say f plus g. All right. Shorthand here. Again, this is really f of x minus g of x. That's what that notation really means. So again, I am going to replace my f of x function with 2x plus 1. Big subtraction sign. This is where you have to be extra careful. And we're going to subtract the entire g function, x squared plus 2x. You need to be very, very careful because you do have to subtract the whole thing. And this is where people make the most mistakes. So if I'm going to test you on something, it's going to be something like this. I'm going to test common mistakes. My goal in this class is that you leave without making those same old negative errors. So 2x plus 1, distributing my negative x squared, negative times positive 2x is negative 2x. And then I can combine like terms. So I have my negative x squared, positive 2x, and a negative 2x cancels out. Hey, that's kind of nice. 0, and then I have positive 1. So f minus g is negative x squared plus 1. Division here, we have the real meaning is f of x divided by g of x. Well, that's not too hard. Again, we're just replacing f of x with 2x plus 1 divided by g of x, which is x squared plus 2x. And I'm going to do one extra thing here, and I don't actually think you would need to do this. So probably this is okay in IXL, but I do want to do one thing because the denominator is not allowed to be 0. I'm going to go ahead and I'm going to do a little bit of factoring on that because I see that there's a GCF there. And so if I took out that GCF of x, would leave behind x plus 2. And I know that that's not allowed to be 0, which means that this thing, x cannot be 0, and here, x cannot be negative 2. And these are the excluded values. And we always really need to pay attention to that. So that's one of the big things we think about in this class. What can we not have? We can't divide by 0. So we definitely don't want that denominator to be 0. But again, I think probably this is all you need for IXL, but I'm always going to talk about denominators and zeros. Here we have f times g. Well, that just means f of x times g of x. And so in place of the f of x, we have 2x plus 1. And this is the whole function. So I want to make sure that I put parentheses around it. And that's going to be times the g of x function. So again, the whole g of x function has many terms. And so we want to make sure that we remember we have to multiply all of it. So this is a big distribute. So we're going to distribute 2x times x squared is 2x cubed. 2x times 2x is 4x squared. 1 times x squared is x squared. And 1 times 2x is 2x. And so the only thing we can do is combine those middle terms. 2x cubed plus 5x squared plus 2x is FG in terms of x. And that's all we can do there. You don't need to worry about factoring that. Greatest common factor is not necessary. Just denominators. Pay attention to denominators. All right, very last thing here. Doing good. I'm loving these notes lately, huh? Not too long, just right. Example 3, perform the indicated operation. So again, what's different about this? I've given you algebraic models here, but these are actually numeric. We don't want them in terms of x anymore. We actually want them with values plugged in. So I'm going to show you how that works a little bit. So first of all, f plus g, this is really meaning f of 3 plus g of 3. Okay, well, I'm going to go back to color coding again. I'm going to say that f of x is this in pink. So we're going to do this. And then our g function in green. So I'm going to do g of 3. So again, what is this telling you to do? It's telling you to take your f function and replace the x with a 3. So we're going to do that. So I'm going to plug in a 3 right there. So -4, and in place of the x, we're plugging in a 3 plus 3. And then my g function, we want g of 3. So again, that's saying, hey, replace the x with a 3. So we're going to do that. We're going to put that 3 in right there. So that would be 3, and we got to square that, minus 4. And then we can just clean it up. So we have -12 plus 3 plus 9 minus 4. Oh, man, math. What is that, -9 plus 9? Hey, that's kind of nice. That's 0, minus 4. All right, cool. Here we have, this really just means f of -1 minus g of -1. So again, we do need to be a little bit careful. We're going to go to our f function, and we're substituting in a -1 in place of the x. So that would be -4 times -1 plus 3. And we're going to subtract the whole g function. You need to be careful. Again, and we're plugging in -1 in place of the x. So that's -1 squared minus 4. So this is in terms of -1 instead of in terms of x. I am going to do this order of operations pretty carefully here. I'm going to go ahead and work inside the parentheses. -1 quantity squared, -1 times -1 is +1. And 1 minus 4 is -3. And so this becomes 4 plus 3, and then here also becomes a plus 3, and we get 10. All right. Here we have f of -2 over g of -2. F of -2 is our little pink function up here. And so we are plugging in a -2 in place of the x. -4 times -2 plus 3 for the numerator. And our denominator, we have plugging in a -2, -2 quantity squared minus 4. What do we get here? Oh, I didn't do it in green. Oh, darn it. I'm not going to rewrite it, though. It was supposed to be green. Okay. 8 plus 3 is 11. And this becomes -2 times -2 is +4. Minus 4 is 0. What? Whoa, undefined. When the 0 is under, it's undefined. We are going to test that all year long, ladies and gentlemen. All right, last and certainly not least, here we have f of -6 times g of, I'm sorry, not negative, f of 6 times g of 6. All right, so this says go to your f function in pink and plug in a 6. So that's going to be -4 times 6 plus 3. And then here we have g of 6. And so that says go to your g function and plug in a 6. So that's going to be 6 squared minus 4. And again, I am going to be pretty careful. This is -24 plus 3, -21. 36 minus 4, 32. And I don't know that math. That is not math I can do. All right. That's a trusty, rusty calculator problem here. -21 times 32, and we get -672. Okay. All right, ladies and gentlemen, lots of practice going between graphs and equations, using numbers and using algebra. Really, really great stuff here. And hopefully this will be smooth sailing for you. Remember, you can always come to office hours or hang out in the Zoom session and ask me questions. Email or text, I'm available. Have a great day, guys.